What is a simple random sample? I wish it was simple. I think the first part of the definition is pretty easy to understand, but what gets people tricked up is the second part of the definition. Okay, so we're going to go through both. We'll give you a couple examples to hopefully make sense of it. And sometimes one of the first places to start is a lot of times when you see this term simple random sample, in statistics we shorthand it and we call it an SRS. So anytime you see this, this is what's called a simple random sample. And before we go into the definition of it and what to look for, um, understand the reason we use a simple random sample is because it's fair. Okay, it's fair, doesn't create a bias. We're not favoring certain people that we pick. It's totally random, left up to chance, and we'll actually show you how to select people randomly in a minute. In order to be a simple random sample, two things have to occur in your sample. Number one, every individual in the population has the same chance of being selected. Okay, so let's start simple. Let's say we're conducting a poll. How many people watch the Oscars? All right, and we want to randomly select a sample of 10 people. We'll say from TCNJ. And just for the sake of making this an easier example, let's say at TCNJ there's exactly 1,000 students. And I'm selecting a sample of 10. Okay, the chance of being selected for this sample would be 10 out of 1,000, or roughly, or exactly, I should say, 1%. Right, I have a 1% chance of being selected for this sample. Every 1,000 students has that chance of being selected. Okay, and it's all 1%. It's not based on anything else. Okay. Now, number two, does this sampling design give every possible sample from the population the same chance of being selected? In this case, it does. And I think the second part of the definition is easier to explain given a situation where this part of the definition is not met. All right, but let's try and explain it this way first. Okay, the reason why the criteria is met here is there's no strings attached. There's no categories that we're putting people into. We're simply saying here's 1,000 people, and we have to select 10. Okay, there's no. It's not that we have to select 5 sophomores and 5 seniors. It's not that we have to select 8 females and 2 males. We don't have to select 3 people that are over the age of 21 and 7 that are under the age of 21. Notice how in each one of those examples there that I'm just rattling off, it presents strings attached or categories. Okay, in this case, there are no such categories. Okay, every single sample has the same likelihood of being selected. So, for example, if I have the sample that has, we'll say the first 10 students in the alphabet. All right. In other words, I have 1,000 students and I list them all in alphabetical order. That sample of the very first 10, okay, Anderson through Aziz, okay, they have the same likelihood of being selected as, we'll say, a more random sample. And I put this in quotes because technically this would be random. Okay, so the sample that has an Anderson, that has a Barrett, uh, um, that has a Danko, that has a Thompson. Okay, those are it's more of a random sample, but the likelihood of this more random sample has the same chance of the first 10 students in the alphabet. All right. Once again, if this part of the criteria doesn't make sense, I'm going to give you another example in red. Okay. So let's come up with the same type of scenario. Okay. We'll say we have 1,000 students at TCNJ. I still want to select my 10 people from TCNJ, but now I want to make sure that we'll say 5 from that sample are male and 5 are female. Okay, is this still a simple random sample? Okay, well, does it meet the first criteria? Does every individual in the population have the same chance of being selected? Okay, in this case, I really don't know because I don't know how many males there are and how many females there are. Okay, let's say to make this example even easier, right? This is not realistic, but let's say out of that 1,000, exactly 500 are male, and let's say exactly 500 are female. All right, if that were the case, if it was exactly a 50-50 breakdown, my sample reflects that same 50-50 breakdown, it's still proportional, everyone in the population still has the same chance of being selected. Right? If I'm a male, I have a 5 out of 500 chance of being selected, which is still 1%. And if I'm a female, again, I'm 5 out of 500, or 1%. Okay, so this criteria is met. Where we run into a problem is the second criteria. Okay, does every possible sample from the population have the same chance of being selected? And the answer here is no. Okay, every sample requires 5 males and 5 females. Okay, and the easiest way to disprove this part of the definition is to come up with a counterexample. Okay, in a counterexample, could I have a sample with 7 males and 3 females? And the answer is no. Okay, the likelihood of me getting 5 males and 5 females is 100%. The likelihood of me getting 7 males and 3 females is 0%. Okay, so every possible sample does not have the same chance of being selected. Okay, it's not a simple random sample. Doesn't mean it's not representative. Doesn't mean it's not a good way to go about doing things. Okay, but it's just not a simple random sample. All right. Now you're probably thinking, well, why is he using the example of the Oscars? And we kind of open that up with the question of using it as an interview question. Do you intend to watch the Oscars? Okay. And the bigger picture here is I think it's another way to kind of look at a simple random sample. All right, in terms of let's just talk about the best actor. Okay, best supporting actor, best actress. Okay, those awards are divided up by gender. All right, if you had 2 females who happened to be the 2 best actors for that year, okay, or best actresses, I should say, if those 2 females happen to be the best, okay, there's still no chance, there's still no way that they can both get what they deserve. Only one of them has that opportunity, okay? So, for example, and again, you would have to have the best male and the best female, all right? Not every possible sample from the population of all actors and actresses has the same chance of being selected. Okay, there's strings attached. There's categories. Okay, so one thing I always fall back on, and I'll end with this, is this word simple is huge. Okay, when you are going through your class exercises, or again, you're just trying to determine whether or not it's a simple random sample, oftentimes if it takes the approach of, we'll say, and I'm just going to write this, numbers in a hat. All right, this is the most traditional way to get a random sample. Okay, I have 1,000 people in my sample. I number slips 1 to 1,000. I mix them all up in a hat, and I select 10. That's a simple random sample. It's simple in nature. I'm not putting any categories, not best female, not best male, all right, not sophomores, juniors, seniors, not over 21, under 21, not students from the state of New Jersey or students from Pennsylvania or students from New York, all right? Everybody's lumped into the same population and everybody has the same chance of being selected. And more importantly, every possible sample from that population will have the same chance of being selected.